All right, here's the um, Excel spreadsheet solution for the maximum flow problem. And again, I just will go through and orient you um, on what the how the spreadsheet is organized. This is not necessarily the way you have to organize yours, but again, much similar to the shortest route problem. You'll see uh, I've labeled cells with the names of each one of the paths, or each one of the pipeways, OA all the way out to T to O. And these blue cells are going to be our decision variable cells. And you'll notice there's one that's different. This TO again is a pathway that's not been it doesn't have a capacity associated with it. And again, these yellow numbers are numbers, actually they're the respective capacities. Again, OA has capacity of 5, B, O to B, 6, O to C, 5, and so forth. So these are capacities. Our objective function is this green cell here, C3, and you can see all I've done is copied this cell. In this case, the formula is just equals Q7, which is the cell location for the decision variable cell location for C. It's T to O. Now again, I've labeled these the flow. It is the flow, but these are really the decision variables for the problem. And let me align that to the left. Okay, so those are these blue cells are the decision variable cells. And then lastly, this area is our constraint area. There's 7 different locations from the origin, destination, and the intermediate locations. And you can see each one of those is a balance constraint. So what's going out of the origin, just like the previous case, it's going to be these cells, C7, D7, and E7. And what's going in, as you might imagine, the only one that's going in is this cell Q7. And so we go all the way through that T to O. The only thing that's going out on location T, the only thing that's going out is TO. And what's coming in is the cells D to T and E to T. And so you can work through all of these locations, and I would suggest that you would to verify in your own mind that they are correct. Whoops. And so E, what's going out of E, anything that starts with the letter E, and you can see E to D and E to T, and what's going into E, there's 3, B to E, C to E, and D to E. So go through all of these and check to make sure in your own mind that they are correct and that you understand how they are derived. Then we're going to go to our solver because we've got everything that we need, the solver, and you saw the solver window in the PowerPoint presentation. We're going to go all the way over to the solver. We're going to open it up. We're going to select our objective function cell, in this case C3. We're going to tell it's a maximization problem. We're going to select our changing variable cells, which are all those blue cells, the flow or the decision variable cells. And then we've got 2 sets of constraints. One of the constraints is the equality constraints, which are everything that's out equals to everything that's in. And then there's another set of constraints where these flow capacities, these decision variable cells except TO are all going to be less than or equal to these values, respective values. So that's our two sets of constraints. Then we're going to go to solver. Again, make everything non-negative, select simplex, and then solve. And then here's our solution. Now this is a little bit more difficult to read, but what you will see is that we can get our maximum value is 14, and you can see the amount of flow. So for example, coming out of O, we have 3 on A, 6 going to B, and 5 going to C. And again, that's 14 units. And if you go through and map this out, you'll see the solution and how those 14,000 units flow through the network. It tells you right away that here there's more information. 3 go through A, 6 units go through B, 5 go through C, 7 through D, and 8 through E. Now, that doesn't mean that 15 is going in, but one of those units from E, I'm going to say from E, goes to D. So there's actually only 14 because they only have 7 going from D to T and 7 going from E to T. So that's the solution. Take a look at it, play with it, see, make sure you understand it. And again, I'm going to place this solution on D2L for you to use and review. Again, call me, email me, text me if you have questions.